Now I would like to introduce the concept of the indefinite integral. The indefinite integral. And it looks like this. Notice that we've looked at these before when we were talking about area under the curve, or total change, or accumulated change. Now we're going to think about this kind of purely algebraically, or with pure calculus. The integral of f of x dx equals capital F of x, which is our antiderivative, plus some constant c, if the derivative of f of x is what I'm taking the integral of. All right? And we kind of saw this in the last chapter when we were talking about total change. The same concept works, right? So this f of x right here, this is the rate of change of capital F of x. So it's almost like saying, I'm going to write this here, I'm going to erase it. The integral of capital F prime of x dx equals f of x plus c. If I do the integral of my derivative, I'm going to end up with my regular function. If I do the integral of a derivative, I'm going to end up with my regular function. This is all this is saying. So this gives us a relationship of how to go back and forth between the function and its derivative. Okay? This is called the indefinite integral because there are no limits. Ooh, and that is crazy. No limits of integration. Meaning, normally we would write the integral from a to b of f of x dx. Well, whenever we don't have these limits of integration, we call this an indefinite integral. An indefinite integral. In order for us to compute these things, we have to remember some formulas, right? So in the last video, I kind of thought my way through finding the antiderivatives. Well, that takes a while, okay? And so we have these formulas here to help us think through what the antiderivative would equal, all right? When we have x to a power, I can almost call this like my power rule for antiderivatives. Then my antiderivative is going to be x to the n plus 1 all over n plus 1. And since it's an antiderivative that's indefinite, I put plus c so I can get the whole family of functions. All right. Notice if I take the derivative of this thing, this n plus 1 here will come out front, and I reduce that by a power of 1, so I get x to the n, and the n plus 1s will cancel. So that works, right? All right, here I have k dx, the integral of k dx. Notice my integral is going to be taken with respect to x. And so since this is a different variable other than x, then I know that k is a constant. So this is like a constant rule. The integral of a constant equals the antiderivative that if I take its derivative, I end up with a constant, which is going to be like a linear function. So it'll be like kx plus c. If I take the derivative of this with respect to x, this is linear, so I'm just going to get k, which is what I have here. Okay? All right, rule 3, the integral of 1 over x dx. This one's weird. It's not really weird. All right, it's the natural log of x plus c. And I put this in absolute value because depending on if the domain where we take the limit of integration, sometimes this x can be negative and sometimes it can be positive. And for this to work right, we need this absolute value here. Most of the time, we'll just write ln of x plus c, but there is an understood absolute value here that makes this stuff work, all right? And I know that this is true because if I take the derivative of natural log of x, I end up getting 1 over x, which is what I start with here, right? And so that's why the derivative, the antiderivative of 1 over x dx is natural log of x. Well, we know that the derivative of e to the x dx is e to the x, or the derivative of e to the x is e to the x. And so if I want to find the antiderivative, this is probably the easiest antiderivative, is e to the x plus c. All right, so these 4 rules are rules that you're going to want to remember for the rest of your calculus experience. These next two rules are kind of like guidelines that allow us to simplify things more easily. If I have the integral of an addition or a subtraction of two functions, this is basically saying that I can do the integral of the first function plus or minus the integral of the second function. Okay, so you don't have to, if you have a subtraction of two functions, you can do the integral separate. Okay, and likewise, when I have a constant multiple, a constant multiplied by my function, what you can actually do is, if you don't want to worry about that function, you can bring it out front as a coefficient to your integral, and you can do the integral of f of x dx by itself there. All right, and so these are some things that may be useful as you try to do some integrals. Let's look at some examples. All right, example 3, find the indefinite integrals. This is another way of saying find the antiderivatives, because the antiderivatives are the actual, what the indefinite integrals are going to give you. All right. And so I'm going to start using some of these rules. Now, in this first example, I'm going to write down some stuff that you probably will get used to not writing, okay? I'm going to use that sum or difference rule that says I can do the integral of 2x dx and subtract off the integral of 1 dx. I can do the integral separately. I can make two separate integrals separated by that same sign that they originally had. This first integral says, oh, well, I have a constant multiple, so I can bring that constant out, and I can do the derivative of that constant. I'm going to keep this 1 in there so I can have something in there, all right? And now this is just x to the first power, so I can use that power rule. I have my constant out front, and I have x, and I'm going to increase that power by 1, so x to the 1 plus 1, all over 1 plus 1. And this is a constant. This is that integral of k dx rule, and that's going to be just 1x. Since this is an indefinite integral, I don't have limits of integration. I'm going to put plus c here. Notice here that this equals 2 and this denominator equals 2, right? Because this denominator equals 2, it cancels with that 2 there, and I'm going to be left with x squared minus x plus c. All right. Remember, anytime you do an antiderivative or an integral, you can check yourself by doing the derivative. So I'm going to do the derivative of this function that I think is my antiderivative. My first term, I bring 2 to the front, reduce the exponent by 1. This is a linear term, understood to be a slope of 1. And so I get minus 1. This is plus 0. We don't need to write that, right? And so I get the derivative is the same thing that's sitting there, right? And so I have my function. We're going to continue in the next video.